I will be going to teach you about a very good way that how using the Python you can just not do these kind of things, but you can plot the things or you can create the graphs. By now, all of you guys should have a fair understanding that either we are doing anything on the Python, we can achieve these things using different libraries which are available into onto our like internet. Okay, same way there are some more libraries which we will be gonna use today, and we will be gonna create the graph. So I would be using two libraries. One library would be network x, second library would be matplot library. So the very first thing what you need to do is, onto your machine, you need to run the command pip install networkx, then pip install matplot. When you run this command, these particular libraries from the internet will get installed onto your PC. And now in your script, whenever you say that, okay, import something from network X as NX or maybe anything. So we are importing this whole library as NX. This is the way how we can use one program into our own program. So two libraries, again, very simple thing. I am not telling you very hard thing. Two libraries are there. One is networkx, one is matplot library. Using this library, we will create a very tough script today. Okay, that is script will log in into the device. Check the show CDP neighbor, and by checking it, it will make the graph of it. That graph will be visible in front of us. It's not an easy job. It took a very great time for me to build this particular program. I search over the different forms as well, and do lot of amendment into that program. Somehow, due to the due to the lack of the timing, okay, I could not more made it easier. Although there is a lot of scope still, but I would be gonna show you how to create the CDP neighbor through your Python script. So this section is known as app section. So let me show you and start with some very basic programs first, and then I would be creating some more programs which would be iterating more or maybe more advanced, I will say. Let me open the folder app. This app has a couple of the programs. First few programs, these 5 programs are very basic. Then this script is a very huge script which we will be learning today, and I would be showing you how you can create your CDP neighbor diagram using the Python. Let us start with this first program. Before creating it, let me just explain about this program. So into this program, if I will tell you what I am doing is, I would be gonna give me a minute. Where is my I will be explaining you about the graphs first. When I am talking about graph in mathematical way, it means that it has couple of the nodes, and these nodes are attached somehow. It can be a bit like this. It can be a bit like this. It can be a bit like this. or it can be bit address. And anyway, okay. So these things, these particular things which are showing in the circle, these are known as nodes, or we also say as vertices. These are nodes or vertices. And this particular connection in between them is known as edge. Are you getting about this point? So there is node, there is edge. Node means the particular nodes. Edge means the connection, the connecting line between the two nodes is known as edge. And as I was telling you, we would be using an network X Python package from the internet to create this kind of graph. Very easy if you will understand, but try to see. First, there are two things. One thing is node, one thing is edge. And the first program is talking about the same. If I will show you, I am just mentioning this whole thing so that in the video you guys can able to see about it. What I am doing in the it is very first line, right? Although it is on the sixth position, but it is very first line. I am saying import network X as an X. So instead of writing down network X always, I can say NX. From this NX, I am calling the graph. This is a way to import something from another module. I am saying from NX, I am calling a function name as graph, and I am saving that into a variable named as G. Only two lines over here. Okay, maybe let me just go here. What I am doing now is from the G, currently print the nodes. There should not be any node. By default, there is no node available. If I will print the edge, there should not be any edge. And if I will print their type, maybe I will print their type in a moment. First, let me see the output of this particular program. But before running this program, kindly be aware, you should have network X installed into your system. I have already did it. Okay, but what you need to do, go to the command prompt, write down pip install and network X. When you run this command, it will start installing if it is not there. My case, it is showing that it is already there. Maybe if I will check mat.lib, it will also say that okay, it is already installed. But into your case, it will gonna install these two programs. I am importing network X as an X into my script, calling it into the G, printing what are the nodes available, what are the edges available. If I will see, there is no node, there is no edge. I can just say over here, nodes are okay. And similarly, I can write down just to make it more interactive, edges are, and then and if I will run again, you can see nodes are no node available, edges are no edge available. So there is nothing, empty list. Whereas if I need to see the type of these nodes or edges, what are the types? So type function, you are aware, like it is a string type, like it is a list type, it is a dictionary. I can print out that also. So I'm just mentioning nodes type from network X is Okay, I'm printing that statement. Similarly, I can, just to make it more interactive, I can write down edges. And just I can comment them out because I know there is nothing over there. And if I will print it out, you guys can see nodes type is belonging from the class network X, reporting as the node view. Edges reporting as the edge view. So these are nodes and edges from the network X. Any doubt? Please ask. Very simple thing, but if you have any doubt, please ask. Motiala, Sandeep, is it clear?
Yeah, no doubt, Jay.
Yes.
So let me go ahead and show you some more iteration by adding the nodes. So now I am adding the nodes. Please understand, let me bring up my whiteboard. I showed you that when you import network X, there are no nodes and there are no edges. It is my job to add the node. I can add the node either one by one, either I can import all the nodes in one go. So there are two methods available to add the nodes, either in one go, either one by one. So let me share again that program. You guys will able to understand. Add one node with the method add node. And if list of node available with you, you can add nodes from method. So what I'm doing, importing network X as nx, then g equal to nx dot graph. Now, if I need to add only one node, I will use this method that I am adding a node and the node name is A, case sensitive. Please understand. If I need to add a complete list, I can add a complete list by such a method that add nodes from, and total nodes would be A, B, and C now. And if I need to print out the nodes of the graph and the edges of the graph, I could see there would be three nodes now. One node I am adding over here, two nodes I am adding over here. So total nodes are three, but edges would be none because we didn't add any edge currently. Let us see this. Nodes of the graph A, B, C. Edges of the graph, nothing. Better to club this thing into the single line. Just to get a good output. Okay. If I will see again, you can see node would be A, B, C. Edges are nothing. So if I will plot such graph will be having the output. Where is my whiteboard? Such graph will be having the output like it has A, it has B, it has C. But since there are no edges in between, so there is no lines. So all of these are like A, B, C. There are three nodes, but no connection in between them. No edges. So we are aware now how to add the nodes. We need to now see how to add the edges. Let us see how to add the edges as well. Into our next program, I am adding the edges. First, Empty graph I showed you. Then I showed you how to add nodes. Now I am showing how to add the edges. I'm just writing down very small programs so that you guys could be able to understand it very properly. Now, when I am adding the edges, try to understand one more thing. When I am saying there is an edge between A and B, it means I am saying two things. The one thing what I am saying is I am talking about two nodes. Those nodes are A and B. And second thing I am talking about the relation between them, that A and B have the edges. So it means when I will add the edges, and if those two nodes does not exist into your node list, it will get added automatically. I hope making sense. Yes or no? Everybody is on the same page?
Yes, yes.
Sure. So let me now show you about the same thing. Okay, one more thing. When you are adding the edges, you can add between a single thing, or you can have like this, between A and C, between A and B, between A and D, or however many. Okay, you can pick it from different like pairs. You can pick it from here, or you can pick by one pair also. So let me show you now the same thing. Again, importing network X, G equal to NX graph, adding the node A, adding the node B. It is from our previous program. So here, adding node, or I can say adding a single, here, adding two nodes from this. What I am doing now, here, defining the connections between two nodes, that is 1 and 2. So one edge, I am adding 1, 2. It means two nodes also get added, that is 1 and 2. Secondly, if I am creating a variable is D and E, I can just add this variable as well. So adding the edge from the variable. So using variable code also I can add it. I can edit it directly like add edge, and whatever edge between the nodes you need to specify, you can specify, or you can parse the variable. Variable should have the nodes available. Also, you could see I can just pick it from a complete list having this kind of tuples available, that okay, A and C and not tuple, it is not tuple, but it is set something. Okay, A, C, C, D, A1. I can just parse out this whole list also. And then I am printing out nodes, I am printing out edges. Again, let me just pick up this whole line from here, and pick like this line. Question for you now, how many nodes are there if I will run this program, and how many edges would be there? Question is clear?
Three nodes and 4 edges.
So if I will run this, here you go. 3 nodes which you are adding by the node function, but 4 more nodes which are getting added when you are explaining about the relation between those nodes. And that is what I was saying. That if you are defining the relation between the nodes, it means if nodes are not there, that will get added automatically. Is this part clear to everyone?
Yes.
Sandeep Mutiala, right?
Yeah.
Okay. Now, if you will check the relation we are defining between 1 and 2. So you can see there is 1 and 2. We are defining between D and E. There is between D and E. Okay, check the only edges. We are defining between A and B. There is the relation between A and B. So if I will plot a graph, this graph will be having these all nodes, but only one connecting line here, one connecting line here, one connecting line over here. That's it. If you will try to see in the connection between 2 and 8, there is no connection. Either you need to define the edge in between them, otherwise there will be no connection. Now, let me just from here to here, let me just comment it out. And let me just use like this. Can anybody let me know how many nodes would be there now? A, C, D, 1, 2. These nodes would be there now because I'm making the connection. So if I will run this script, you can see that is what and how the connections is in between them. What are the edges that we can also see. Anything? Any question? Is back. So, Sandeep Mutiala.
Yes, yes.
Okay. So before coming to the main, topic, let me tell you, okay, both of you one detail. What we are going to do is we are launching the LTM GTM ASM batch. I hope Sandeep you are already having this, right? You have already gone through these batches, but
Yes.
Mutiala for you and for you also Sandeep, if you can, if you are not interested maybe or you have the knowledge, please refer to your friends. Okay, so these batches are going to start it from the next weekend, and probably if you can help us out, that would be great.
Yes, yes.
Apart from it, we are running with Palo also. Okay, this weekend, and from next month we are launching CCI Enterprise batch. So that will be having the technology classes of 80 hours. 80 hours minimum, more than that. So we would be launching up that CCI Enterprise batch also. If anybody is interested, please do let us know. Now let's come to this topic. For CDP neighbor detail, we need to do a lot of tweaking. Like what? Like first, I will be accessing to this device. To get the SSH access, I can use anything. I am using NetMinion over here. Everyone is aware about the NetMinion now. Using NetMinion, I am running a command. First command, I will run the show run. In the show run, I will check the host name. That what is my host name? I will try to find out. Second command which I will run the show CDP neighbor detail. Out of this command, if I will run this command, let me show you how would be the output. If I will run this command, it will give me all of these things, that what are all are the devices which is connected with me. Like here, device ID r3.netminion.net, device ID switch to .netminion.net. Okay, then internet gateway, it is talking about its own. So these device IDs which are coming in, this is what we need to find out. So we will find out these things. First, we will pick all of the output, and all of the output will be converted into the list. Okay, we will be making it all the output into a list. Every line would be the element of the list. Then from this element, we will find out device ID. Once device ID is there, we have something in our hand. From this device ID, we will remove this device ID field, and we will pick up this whole field like r1.net, minion.net. From here, we will make it r1 netminion net, which is a separator dot. We are just removing this separator, and on the basis of this separator, we will remove rest of the things. And then we will pick somehow the r1. So by this way, we will be saving all of the CDP neighbor detail in a file, in a text file. So this particular script is containing two like modules. In one module, we are saving the text file like on which switch you are, that switch is there. Then what are the devices connected to it, like R1, R2, R3, those devices are there. Then into the script 2, I am getting these inputs, adding these as nodes, describing the edges, that these are the edges. These would be the edges. And using Metaplot library, making the graph. Okay, that is how this whole logic is coming. So far, any doubt? Logic is clear to everybody? Yes or no?
Yes, yes.
Yes.
Okay. Router 4 is showing. Okay, you can see router 4 is also showing now. Perfect. Let me just run this script again then. I am running this script. It is asking again for the 151.1.1. And if I will wait, can you see router 4 is also up. So this is showing you how many devices connecting with